Okay, here we go. Grade 3, Module 5, Lesson 5. This here is a chart that we're going to fill out, and we're going to look at the holes. So each image over here on the left we see as a hole, and then we need to figure out what all these things mean. Total number of equal parts, total number of equal parts shaded, unit form, and then fraction form. Just like we talked about in the objective, the fraction form is numeric form. The unit form is how we write it out in words, okay? So we're going to go through this together. Once you feel like you got it, pause it and then try it on your own. And then play the video again and see if you're right. Okay, so here we go. So fill in the chart, each image is one hole. Total number of equal parts. Well, I see a triangle that's cut into two parts. There's two equal parts. See? 1, 2. Total number of parts shaded. Well, that's just 1. Write down 1. My unit form. Okay, we've been writing this down as in words, so my unit form is 1/2. Right? So that's the unit form is 1/2. Okay? And then my fraction form is how we write it as a number. All right, with numerator and denominator. So we'd write this 1/2. Okay? Now there's lots of fancy ways you could write this. I mean, some people write it with a slant like this. I like to just keep it this way, simple, so we know, and then as we understand fractions more, we can get into a fancier way like that. But the choice really is yours right now. Okay, let's continue. Down here is, I see this part is a hole, and I see 1, 2, 3 parts. All right, and here I see one part is shaded, and unit form would be 1/3. So my unit fraction form is 1/3. Okay, on to the next one. Here we go. The total number of equal parts, 1, 2, 3, 4, that's 4. And then here, 1 shaded. My unit form is 1. Two ways you can say this. You can say 1/4 or 1/4. I'm from the school of only saying 1/4, but the other way is just fine too. 1/4. Okay. Down here, I see a kind of a pattern developing here. 1, 2, 3, 4, 5. Okay, so this is fifths. So I'm going to say there's 5 equal parts. One of them is shaded. 1/5 is in words, and then as numerically, numerator is 1. Parts that we're talking about is shaded. Out of 5, denominator 5th. Okay? Over here, 1, 2, 3, 4, 5, 6. 6 parts. 1 shaded. Unit form would be 1/6. And then number form, fraction form, is 1/6. Just like that, numerator and denominator. Total number of pieces, total number we're talking about. And then finally down here, you would think this would be 7 pieces, but it's not. I see 2 rows of 4, which is 8. And then 1 shaded in, so there we go, I got 1 part shaded. And then here is 1/8. Just like that, okay? And then finally, fraction form is 1/8. Perfect. Okay. And that's the front. Now, if you pause this and went on your own and did it, and then checked in with me, hopefully you're right, okay? Pretty straightforward once you understand what you're doing, okay? And once you understand what unit form and fraction form means up top, all right? And it's pretty straightforward, okay? So let's move on to the back part. And here we go. I've got this part here, and I'm going to read this out loud, and then we're going to answer the question. Andre's mom baked his favorite 2 cakes for his birthday party, period, stop. These cakes were the exact same size, period, stop. So I can see here that there's a cake here and there's a cake here. But this is part of the other question, so we'll see. All right, see that? 2 cakes. But we'll see what's going on here. All right. Andre cut the first cake into 8 pieces for him and his 7 friends. Okay, him and his 7 friends makes 8. 7 and 1 is 8. The picture below shows how he cut it. Did Andre cut the cake into eighths? Explain your answer. So let's take a look at this cake down here. Now, I don't know about you, but if I were at this birthday party, I'd be clamoring for one of the bigger sized pieces, right? Everybody's like, oh, give me that piece. Just like when I bring pizza into the classroom on a pizza party, everybody's looking for the biggest piece. So here, this is cut into 8 pieces. That's true. But this is not cut into 8s because they're not equal sizes. Now, it is super important that when you are cutting something into fractions that you have equal parts. You need to cut the whole into equal parts. You need to partition it into equal parts. And if it's not equal parts, you do not have fractions. So this here is not fractions. So did Andre cut the cake into 8s? No, he didn't. Explain your answer. We're going to do that using that number of partition into equal parts, okay? So we're going to write down, no, Andre did not cut the cake into equal parts. Oops, I'm sorry. Getting ahead of myself. Did not cut his cake into 8s. Right? I'm sorry about that. So we'll do that into 8s. Period. Okay? In order to make fractions, comma, you need to partition, which is a fancy word for cut, the whole into equal parts. Okay? And I'm going to circle equal parts, put big stars around it. All right? If you can use the word equal parts in your explanations when talking about fractions, you're going to win every time. Okay? So make sure that you take a picture of that with your brain and log it in there. Okay? All right, on to the next one. 3 says, oh, here's a second cake, and it's the same exact size as the top cake. 2 of Andre's friends came late to his party. They decided that they will share the second cake. Show how Andre can slice the second cake so that he and his 9 friends can each get an equal amount with none left over. Period, stop. All right. What fraction of the cake will each receive? All right, so 2 more of his friends showed up. So he doesn't have 7 friends anymore. He's got 9 friends. Right? That says right there he's got 9 friends, but we have to include Andre in that as well. So Andre and his 9 friends makes 10. So how many pieces do we need to cut, partition this whole into? If you said 10 pieces, you're correct. So 10 pieces. So the best way to do that is I'd like to have a line going across like he did. And so we need to go cut this into fifths first. So 5 is going to be 4 equal parts. So I'm going to have to put little tick marks up here, kind of 4 cuts down, and go from there. I'm going to erase this one and bring it over a little bit. Bring this one over a little bit. All right, and then I'm going to cut this down, do the best that you can, into fifths. 4 cuts is going to give me fifths. Now, the reason why I did fifths is because if I cut all those in half, I'm going to have tenths. So all I need is a single line to go across this way. And there we go. So that's that the second cake would look like. Now, I did this freehand, but you can see that I tried to partition this as equally as possible. So each one of these pieces is a tenth, it's 1/10. So what fraction did they cut the cake into? Well, they each receive? Well, they're each going to receive 1/10. So they each will receive 1/10 of the cake. Sounds good. Okay, on to the last part here. And Andre thinks it's strange that 1/10 of a cake would be less than 1/8 of a cake, since 10 is bigger than 8, period, stop. A lot of kids would think that. They think down here, 10 and 8, well, 10s get bigger, right? Well, not in fractional world. The more pieces you have, the smaller the pieces are going to be. I mean, I don't know about you, but I would rather split a candy bar with just one friend than with 10 friends, right? So if I split it up in half, 1/2, man, we each get a half of a candy bar. But if I take a candy bar and split it into tenths, that means I get 1/10 of a candy bar. Even though 10 is bigger than 2, that means I get a really small piece. So you think of it that way in real world applications, you're going to understand fractions a whole lot better. To explain to Andre, draw 2 identical rectangles to represent the cakes. Show 1/10 shaded on one and 1/8 shaded on the other. Label the unit fractions and explain to him which slice is bigger. So I only have about 4 minutes to explain this, so here we go. The best way to do this, 2 identical rectangles, is I'm going to make one big rectangle like this, and then put a line down the middle here to make 2. Okay? So up here is going to be my 1/8 rectangle, and down here is going to be my 1/10 rectangle, okay? So up top, I'm just looking at this as my eighths, 7 cuts. Down the middle, cut those in half, cut those in half, cut those in half, good. And I got 1, 2, 3, 4, 5, 6, 7, 8. And I'll shade in 1/8 here, okay? Now my bottom triangle, which is touching the top rectangle, which is touching the top rectangle, is going to be tenths. So I can also split that in half because 10 is equal. And then I got to have 4 cuts over here. So I'm going to have 1, 2, 3, 4 cuts. And over here, same thing. 1, 2, 3, 4 cuts. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I shade in 1/10, I can see that 1/10 is smaller than my 1/8. See that? These pieces are smaller, not by much, but they're definitely smaller, all right? And doing it this way is a tough way to do it. Tenths and eighths are really, really close in size, but eighths are definitely bigger because there's less pieces cut up. All right, so 1/8 is bigger than 1/10, period. The larger the denominator, the smaller the piece. Okay? So you see the larger this denominator here, the smaller the piece. I mean, could you imagine if that was 1,000? If I had to cut this up into 1,000 pieces, could you imagine the size of the pieces? There'd be a sliver, okay? So you think of it that way. So the more pieces, the denominator is how many pieces, the smaller that piece is going to be. So the larger that is, you're going to see really tiny, tiny pieces. All right, so this is our lesson today in a nutshell. Hope that you're safe and happy at home with your parents and working hard. And, just now go to your quick check in your Google Classroom. Do your best on it. It's a little bit different today. You get to answer questions as writing that as opposed to multiple choice. Do your best on it. I just want to try something different this week. And again, any questions, please let me or your teacher know, and we'll figure it out. All right? Thanks so much, guys. Hope you're safe.